Crabs go sideways, they don't go back. They can't go forwards, they haven't got the knack. They can't wiggle or jiggle, roll or leap or jump. They just go sideways until they hit a bump.
In terms of behaviour, we've focused particularly on behaviours that will be crucial to that crab. So two of those are foraging, so how these crabs are eating, and also their response to a simulated predator. To look at foraging, we had crabs in environments. Crabs often will eat mussels, and so we had crabs in tanks with mussels and looked at how they performed both with playback of ambient conditions, so just the background noise of the sea, and compared that to their behaviour when they had the noise of ships. We found that they were far more likely to leave food. So they didn't do so badly in terms of finding food to start with. They were just as likely to find the food, but they would often then seem to get disrupted from feeding, leave their food before they'd finished eating. In terms of the anti-predator response, we simulated a predator attack, not a serious attack, but we had a stick that we would approach them with in a very controlled way. And we looked to see whether, first of all, they detected that simulated attack, and they did, whether they were in noisy environments or not, but also then how long it took them to retreat to shelter. And they were accustomed to their environment in the tank, so they knew where shelter was. And they took much longer to get back to shelter if they were in noisy environments. There's another very important behaviour in crabs, which is if they're turned upside down, you might think the natural thing would be to turn back over as quickly as possible, but this attracts attention to potential predators. So crabs will often delay their righting before they then turn back over. And in noisy environments, their righting behaviour was affected too. We also looked at physiology, so in this case we were measuring oxygen levels in the water, and we found that there was a higher oxygen uptake by crabs in noisy environments. So we think the crabs were stressed because of the noise, and we found that big crabs were disproportionately, relative to their body size, stressed more. So that could have impacts on which crabs are more vulnerable to noise.
The seaweed is always greener in somebody else's lake.
Do you think your research has flagged up that when we're thinking about the overdevelopment and use of places like harbours and the seaside through like the Marine Management Organisation, that noise, the sheer noise of the engines chugging, needs to be considered as well as other more obvious forms of pollution?
Absolutely. So I think there's a growing recognition that noise is something we need to concern ourselves with now, and potentially people are calling noise the new pollutant. You know, we've had chemical pollution, we've had various types of pollution. Noise is something that we'd probably been ignoring until quite recently. The exciting thing with noise as a pollutant is that we can control it very easily. We can choose where we make noise, when we make noise, how much noise we make.
Obviously, if they're responding to noise, then there might be certain sorts of noise that they might respond to, different frequencies. Being a radio station, you can imagine where we're going with this. Whether there might be certain types of music that crabs would go for. Is that the next step for your research?
Well, so we did actually run that experiment once. But originally, I got interested in marine noise because I was looking at how coral reef fish at the end of their early development out at sea could find a coral reef. They'd spend a few weeks developing in the plankton, and they've got to find a reef. And so we were doing a lot of experiments playing back reef noise to our fish and looking to see whether they could discriminate between different types of habitat. So we had lots of loudspeakers and choice chambers and so on out in Australia. And it came to Christmas Day, so we decided to look at whether fish could tell the difference between M&M and the Chemical Brothers, which it tells you how old it was, but those were the two types of sound that we had to play back to them. Interestingly, there's a study just out because people are starting to use music in aquaculture as a way of trying to reduce stress on the animals or even promote growth. And there's a study recently that shows that if you play goldfish, John Lee Hooker, so some blues music, you can train it to swim to one end of a tank and it'll take its food reward. And if you play it Miles Davis, it will swim to the other side and it will choose the jazz music. If you then play some other type of jazz music, Charlie Parker say, it can sort by genre. So if ever you're desperately trying to work out the last possible way of sorting your CD collection, then ask a goldfish, they're able to sort sounds by genre, so they can clearly pick up different frequencies, different patterns in the music. And I think similarly, coming back to anthropogenic noise, that's a key question in terms of what kinds of noise cause the most stress. Is it very loud noises? Is it very repetitive noises? Is it noise that's chronic, like shipping noise, or is it the very acute banging of pile driving? And we're now starting to use both fish and invertebrates, particularly crabs, to try and explore those questions. Yeah, they are certainly important questions.
Anyone who's taken children to the seaside would know that the crabs have a peculiar hold on our imagination, don't they? You spend a lot of your life, obviously, with crabs and invertebrates. What do you think of our friend, the crab?
Oh, no, they're fantastic animals. I mean, they're great for working with in experimental conditions. One of my favourite questions, actually, we often go into primary schools and take marine animals, and crabs are great because they're robust and they don't seem to mind children having a look at them and things. One of the questions that I was once asked, which I really enjoy, was a child who came to me and said, I've just got one question about crabs. Do you think that crabs think that humans walk sideways? Which I thought was brilliant. It just, again, it captures how alien they are, you know. And you look at many sci-fi films. What do the designers use when they try to design an alien? They look at a marine invertebrate and start from there.